Hi, sir. Welcome to my presentation. The topic is Ohm's law and its applications. My name is V. Gautam. My road number is 21951A1227. My branch is IT section. According to the Ohm's law, the voltage or potential difference between two locations is proportional to the current of electricity flowing through the resistance, and the resistance of the circuit uh, pro- proportional to the current or electricity traveling through the resistance. V equal to IR is the formula for Ohm's law. Uh, George Ohms is a German physician discovered the connection between current current and voltage and relationship. Let's take a closer look at Ohm's law, resistance, and its applications. And the next is what is Ohm's law and Ohm's law formula. Now, first, what is Ohm's law have? Voltage, current, and resistance are the three most fundamental components of the electricity. Ohm's law, it is a deeply straightforward relationship between these three variables. According to the Ohm's law, the current flowing through a conductor and also between two locations is proportional to the voltage across the conductor. And next is Ohm's law formula. Ohm's this is the one of the most fundamental electrical rules. It aids in the calculation of an elements power, efficiency, current, voltage, and resistance in electrical circuit. Now Ohm's law formula is V directly proportional to the R. V equal to mm, V equal to I into R. And the next is the SI unit of resistance is Ohm's law, and it's denoted by ohms. Applications of Ohm's law, and also applications of Ohm's law when the other two numbers are known. Ohm's law may be used to determine the voltage, current, impedance, or resistance of a linear electric circuit. Main applications of Ohm's law: it also simplifies power calculations. And the next point is to keep the desired voltage drop between electrical components. Ohm's law is employed. The electric circuit's voltage resistance of a current must be determined. The next point is Ohm's law is also utilized to redirect current in DC emitters and the DC shunts. And the next is how do we establish a current voltage relationship? The ratio V by I remains constant for a given resistance. For a given resistance, for establishing the current voltage connection, hence a graph of a potential difference V and I must be a straight line. And the next is how can we discover the unknown resistance values? And the next is the constant ratio is what determines the unknown resistance. The values, the resistance of a wire with a uniform cross section relies on the length and the cross section area. It also relies on the conductor temperature. The resistance at the given temperature are equal to PL by A. And next is here's the P is the specific resistance or a resistivity, and is the wire's material characteristics. The wire's material specific resistance or a resistivity is P equal to RA by L. Limitations of Ohm's law. The law of Ohm's does not apply unitarily networks. The current can only flow in one direction. Is unitarily networks, diodes, transistors, and other electronic components are used in the sorts of the networks. And the next point is non-linear components are also executed. Ohm's law non-linear components have a current that is non-proportional to the applied voltage, which implies that the resistance value of those varies depending on the voltage and the current. The resistor is an example and the non-linear element. And the next is resistors. One of the most important components in the electrical circuits is the resistors because they are the comprised of the clay carbon combination. They are the good conductors and the good insulators for four color bands are seen. So majority of the resistors, the first and the second band shows the values. First and second is respectively the value. It is multiplied the third band, and the tolerances is determined in the fourth band. There is not fourth band, the tolerances is presumed to be plus or minus 20% resistance in series. A series is a group of related items such as a long uh, along along a line in a row or in a certain order in electronics. Series resistance implies that the resistors are linked in the series, and that current can only travel via one channel. And the next is loss of series circuits. In this, we have 3 points. The first point, the overall circuit resistance is the made up of individual resistance, and the second is the total voltage is the sum of the individual voltage in the circuit. The third is every point is the circuit has the same amount of current flowing through it. And the next is resistance in parallel. A parallel circuit is the organized in the variety of waves. And the next is the majority of the wiring in the real world is the done in a parallel uh, such that the voltage provided to any one provision of the network is the same as the voltage given in other section of it. And the next is loss of parallel circuits. All of the components resistance reciprocals add up to the overall circuit resistance reciprocal. And the next point is the total current draw in the sum of the individual current pulls across the circuit. And the next point is every point is in the circuit has the same voltage. In January 1781, before George Ohm's work, Henry Cavendish experimented with the Leven's jars and the glass tubes of varying diameter and length filled with salt solution. He measured with the current, noting how strong a shock he felt. He completed the circuit with his body. Cavendish wrote that the velocity current varied directly as the degree of the electrification voltage. He did not communicate his results to other scientists at the time, and his results were unknown until Maxwell published them in 1879. And the next is Ohm's law was probably the most of the important of the early quantitative decisions of the physics of the electricity. We consider is almost obvious today. The when the Ohm's law is published, his work and his was not case secretaries reacted to a statement of the subject hostility. They called as his a web naked faces, and the Minister of Education proclaimed that a professor who preached is was unworthy to teach science. The prevailing scientific philosophy in Germany at the time arrested the experiments need to perform to develop an understanding of nature, because nature is so well ordered, and that scientific truths may be decided through reasoning alone. And Ohm's law, brother Martin, a mathematician, was battling German educational system. These factors in acceptance of the Ohm's law and it did not became widely accepted until the 1880s 40s. However, Holmes received recognition for his contribution to science well before he died. He did. He died. Sorry. And the next is the electron was discovered in 1997. James Thomson, and it was quickly released. It's a particle charge carrier that carries electric currents in the electric circuits in 1919. The first classical model of the electrical conduction, the diode model, was proposed by Paul Diode, which finally gave a scientific explanation for Ohm's law. In this model, a solid conductor contains a stationary lattice ions, and the conduction electrons are moving randomly in it. A voltage across the conductor causes an electric field accelerates the electrons in this direction of the electric field, causing a drift of the electrons, which is the electric current. However, the electrons collide, atoms which causes scatter and the radiation in their motion, thus converting their kinetic energy of the heat using the statistical distributions. It can be shown that the drift velocity and the electrons, thus the current is proportional to the electric field and this voltage over a wide range of the voltages. And the next is the development of quantum mechanics in the 1920s modified this picture somewhat. Modern theories average drift velocity of the electrons can still been shown in the proportional in the electric field, thus deriving Ohm's law in 1927. Aaron Sommerfeld applied to the quantum Fermi distribution of an electronic emergencies to the dude model, resulting in a free electron model. A year later, Flex bound showed the electrons move in a wave, bounces electron through a solid crystal lattice. So scattering of the lattice atoms has postulated in the rigid model. In the major pros, the electron scatter the impurities, atom defects in the material. The final successor in the modern of the quantum theory has shown in the electrons shown in the electrons of the solid cannot take any energy as assumed in the Drude model, but their restricted energy bandwidth, the gaps between the energies and the electrons for the far being has size, and the band gap is characterized is the particular substance which is graded to do with electrical resistivity, explaining why some substances are electrical conductors and some semiconductor and some insulators. And next is while the old term of the electrical conduction, the inverse of the resistance unit ohm is the still used. A name of Siemens was adopted in 1971, honoring Ernest Werner is the Siemens of the is preferred the former papers in 1920s. It was discovered current through a practical resistor actually has a statical fluctuations which depend on the temperature, even when voltage resistance exactly constant. This fluctuation now unknown as Johnson laws, and is due to discrete nature of charge. Thus, terminal effects implies that the measurements of the current and voltage that are taken uh, sufficiently short periods of the time by yield the ratios V by I that fluctuate from the value of R implied at the average of the measured current. Ohm's law remains correct. The average in the case of ordinary resistive Ohm's circle long predictions Maxwell equations, and the understanding of the frequency depends on the effects in the AC circuits. Modern developments in the electromagnetic theory in the circuit do not Ohm's law when the evaluated within the approach and the limits. Thank you.